Alright, this is an Ohm's law qualitative demonstration looking at the relationship between voltage, current, and resistance. And we're going to demonstrate that using two water bottles that have a couple holes cut in the top of them. So if you look, we have two different sized openings cut into the top of each bottle. This one has a pretty small opening, this one has a larger opening. So the size of the opening is designed to represent different resistances of each bottle. The larger resistance bottle is going to be the one with the smaller opening. Okay? If you have a smaller opening, that's designed to relate to a narrow wire that has naturally high resistance. The large opening is smaller resistance, which is designed to simulate a wire that is very wide and thus has naturally low resistance. The other two things we're going to measure are voltage and current. Right? Voltage is about voltage in a circuit has to do with the amount of push that the electrons feel to move around the circuit, and we're going to simulate that by either squeezing or not squeezing the bottle. And then the current is going to be the amount of water that flows out. Alright, so here we go. Here is the low size opening, small opening, high resistance, and you can stand up. I think it's better like this. So here is the bottle. It has a hole in the back side too. And this is not coming out very much. Alright. However, if you increase the voltage and squeeze it, now all of a sudden we have a larger current, as indicated by our larger water flow. So again, if we are not squeezing it, low voltage is low current, higher voltage is higher current. If we switch bottles, this is now our large opening and low resistance bottle. So with low resistance, we're going to get more current. Right? Lower resistance, that's more current. The larger opening is going to have more water flow. If we increase our voltage, we squeeze this. Again, larger voltage is going to be large current flow, and especially with this low resistance, you get a pretty high current flow. Let's get this back. Right. So again, so here's low voltage, high voltage. And just to remind us what the other one looked like, this is our high resistance bottle because it has the small opening. The high resistance bottle. Alright, it's going to end up with lower current. Even if we squeeze it as hard as we can, the higher resistance is going to have less current than the low resistance. And that is Ohm's law.